Everybody has observed the difficulty that a little child has in realizing that it must step over a comparatively high object on the floor. It has no notion of falling. It is delighted and astonished as, from its eminence on the table, it watches you bend down and disappear, and then rise up again and cry, "Peekaboo." This inability on the part of babies to comprehend a third dimension is well known. Now, very serious and bespectacled geometricians tell us that perhaps we too are but babies in a space of a fourth dimension, and that we too might be no less astonished if beings from that world choose to play peekaboo with us. In order to get some notion of the fourth dimension, let us, first of all, get an idea of the meaning of dimension. The dictionary gives it as extension in space. Every material body, such as a tree, a horse, a sheet of paper, is known as a physical solid, and the limited portion of space it occupies is known as a geometrical solid, because it extends in three directions. And we speak of every object as having three dimensions: length, breadth, and thickness. Yet, although a very thin sheet of paper is a solid, we can think of its surface only, and although a tree is a solid, we can think of its height only, without any reference to its diameter. This is true, for we do have the linear measure with its inch, foot, yard, and we have the square measure with its square inch, square foot, and square yard. Indeed, we may get an idea of the cube by drawing, first, a straight line, then another straight line perpendicular to the first at its extremity, forming a square, and then a third line perpendicular to the other two at the same extremity. But having the solid, our experience does not permit us to go any further. However we move the solid, we still generate a solid and nothing else. Nevertheless, let us be bold and imagine that we move the solid into a space that it did not previously occupy, and that we make it take an added dimension that it did not previously have. We now get an object of 4 dimensions. It may be difficult for us to form a conception of a world of more than 3 dimensions. Yet it is no more difficult than to imagine a world confined to only 2 dimensions, or than, for beings of such a world, to form a conception of our space. For simplicity, let the 2-dimensional world be a plane, though equally well it might be the surface of a sphere. We may picture to ourselves the mode of life of the inhabitants of this flat land. They could move in any direction along the plane, but they could not move perpendicularly to it, and would have no consciousness that such a motion was possible. They would not be able to turn their heads up and down. Things about them could be pulled or pushed in any direction, but they could not be lifted up. People and things could pass around each other, but they could not step over anything. Their plane geometry, however, would be exactly like ours. In this supposed land, let us draw 2 straight lines perpendicular to one another, that is, 2 straight lines intersecting at right angles at A. The drawing would be as perfectly conceivable to our plane beings as it is to us. But suppose we asked them to draw a 3rd line perpendicular to the other 2 lines at the same point of intersection A. That would seem absurd and impossible to them, just as it would be to us if we had to draw the required 3rd line on the paper. But with this condition removed, we can leave the plane surface of the paper and draw the 3rd line through the paper perpendicular to the surface at A, just as we might stick a pin at A vertical to this page. So too with us, when we have a cube after drawing 3 mutually perpendicular lines, and are required to draw a 4th line passing through the same point, perpendicular to all of the 3 lines already there. In our space, the problem is absurd and impossible. Our conceptions do not admit of more than 3 dimensions. But for a being that could conceive of a 4th dimension, the problem would be easy. He would simply draw the line through that space. Our conscious life is in 3 dimensions, and naturally the idea occurs whether there may not be a 4th dimension. No inhabitant of Flatland could realize what life in a world of 3 dimensions would mean. Yet, if he were intellectual, he might be able to extend the analytical geometry that applied to his world so as to obtain results true for a world in 3 dimensions, a world that would be unknown and inconceivable to him. Similarly, we cannot realize what life in 4 dimensions is like, though we can use our analytical geometry to obtain results true of that world or even of worlds of higher dimensions. If we place the dweller of Flatland inside a circle or inside a rectangle drawn on his plane, he would be as truly imprisoned as we are in a closed prison cell. He would go all around, and, finding every inch of it closed, he would simply despair of getting out, unless he could break through it. On account of his limited conceptions, he could not possibly understand how we might step over the boundary. He could form no notion of the trick. But we should simply step over the line and reappear on the other side. So, if we, confined within the 6 surfaces of a dungeon, a being able to move in the 4th dimension, he would step outside of the cell without breaking any part of the walls, ceiling, or floor. He would do it as easily as we could pass over the circle drawn on a plane without touching it, so wonderful to our friend in Flatland. Our new being, the 4th dimensional one, would simply disappear from our view like a spirit, and then reappear again outside the prison. He would only have to pass through the 4th dimension. In the 7th book of the Republic, Plato imagines a group of prisoners chained at the mouth of a cavern. All movement is impossible to them. Their eyes are constrained to look upon the opposite wall of the cavern forever. Thus they never see anything except their own shadows, together with the shadows of whatever objects may come in contact with them. In time they come to refer all their experiences to their shadows, and finally they identify themselves with their shadows. By conceiving a possible state in which man is limited by his consciousness to less than what he really is, Plato cleared the way for the notion that the normal man is likewise limited by his consciousness to less than what he really is. This greater, which Plato strove to find, is thought by some to involve the 4th dimension. Let us continue our analogy further. We know that the cross-section of a line is a point, that of a surface, a line, and that of a cube, a surface. Hence, if a 4th dimensional object were cut crosswise, its section would be a cube, that is, a 4-dimensional object is bounded on all sides by solids. Again, on a line we can find 2 points equidistant from each other, for example the points B and C with the single distance BC. In a plane we can find 3 equidistant points, as the vertices of an equilateral triangle in which AB is equal to BC is equal to CA. In our space, 4 equidistant points can be located, the vertices of a tetrahedron, that is, a pyramid having 4 triangular faces. Hence, in 4-dimensional space, it should be possible to find 5 equidistant points. Further, rotation in a plane takes place about a point, in our space about an axis. Hence, in 4-dimensional space, rotation should take place about a plane. This last point, rotation, leads to a curious geometrical application of the principle. We have 2 triangles, of which the sides and angles of the one are equal to the corresponding sides and angles of the other. We can lift one triangle up and turn it over on the other so that the two triangles fit exactly together. But mind, we could not do it otherwise than by lifting. Hence, these two triangles could never be fitted together by the mathematicians of Flatland, since to them lifting is inconceivable. We have a somewhat similar difficulty in our geometry. Let us suppose two pyramids, similarly related. All the faces and angles of the one correspond exactly to the faces and angles of the other. Yet lift them about as we please, we could never fit them together. If we fit the bases together, the two will lie on opposite sides, one being below the other. Again, we may conceive of two solids, such as a right hand and a left hand, which are exactly similar and equal, but of which one cannot be made to occupy exactly the same position in space as the other does. These are difficulties similar to those experienced by the inhabitants of Flatland in comparing the triangles. But it may be conjectured that in the same way as such difficulties in the geometry of an inhabitant in space of one dimension are explicable by moving the figure temporarily into space of two dimensions by means of rotation round a point, and as such difficulties in the geometry of Flatland are explicable by moving the figure temporarily into space of three dimensions by means of rotation round a line, so such difficulties in our geometry would disappear if we could temporarily move our figures into space of four dimensions by means of rotation round a plane, a movement quite inconceivable to us. Furthermore, attempts have been made to find, in the space of four dimensions, explanations of certain difficulties or apparent inconsistencies in physical science. Thus, the behavior of the atoms in certain carbon compounds has been attributed to their motion in the fourth dimension. Attempts have also been made to explain the properties and constitution of matter by means of space of four dimensions. One writer has even argued thus: if a finite solid were passed slowly through Flatland, the inhabitants would be conscious only of that part of it which was in their plane. That is, they would see only a surface, or the section of the solid by their space. They would see the shape of the object gradually change and finally vanish. In the same way, if a body of four dimensions were passed through our space, we should be conscious of it only as a solid, namely, the section of the body by our space, and as it moved along, we should see its form and appearance gradually change and finally vanish, perhaps. Again, the idea of a fourth dimension has been made ridiculous by the suggestion that spirits probably dwell in that dimension and can appear to us and disappear at pleasure, thus offering an explanation for the so-called phenomena of spiritualism. But whatever else we may think of these theories, we can certainly admit the possibility of a fourth dimension, even if it be only for the sake of mental gymnastics.